Hello everyone, Dave from Overkill Audio here. I wanted to do a quick little video on a neat TPA3116 kit that I found. I've been doing a lot of work with an OEM motorsports audio systems that use the TPA3116 chip. I remembered seeing that Parts Express had sold these little red boards for a fairly inexpensive price. I think it was under $15. In fact, I think at one point they were on sale for under $10. I bought one of these, was a little disappointed with it. I couldn't quite get 50 watts per channel out of it. And there were some things about this that I didn't like. Shortly after I tested it, I was only getting about 30 watts a channel out of it. I promptly destroyed it. Not by any electronic means, but because I tried to straighten this heatsink on it. This is actually my second one of these boards. The first one, the heatsink was off kilter a little bit. I tried to pry up on it, assuming it was taped on there. Found out that it was actually epoxied or glued on there in some manner. And as soon as I tried to pry up on this heatsink, I promptly ripped the chip right off of the board. That's when I started really looking at this board and found that the traces on here are incredibly thin. 1 ounce copper circuit boards are pretty thin traces, but this is even thinner than that. I mean, these are maybe 1/4 ounce traces, if even that. After I started looking at it, I started seeing a lot of things I didn't really like about it. One, the power comes in, goes through this diode here, comes through this little switch here on the front. So there's some losses there coming into it. The traces being so incredibly thin, I started doing some of the math on it and started thinking about it, like, 50 watts at 4 ohms is actually quite a lot of current. So if we actually do the math here, 14.14 volts divided by 4 ohms equals 3.53 amps of current. So 3.5 amps of current is flowing through there. And we'll come back to that number here in just a second, but just to continue this math for anybody who doesn't know, excuse my terrible penmanship here, 3.53 amps times 14.14 volts equals 49.98 watts. So that's pretty close to our 50 watt target. So getting back to this, 3.5 amps of current into a 4 ohm load through these little tiny thin traces on here. And then if you look at these inductors, and I don't know if I can zoom in here enough to, so these inductors are pretty small to be handling 3.5 amps of current on these little boards here. So I wasn't too terribly impressed with it. Plus this heatsink is very, very small. And if you're going to be running this board hard at all, this heatsink is just not going to cut it. So I started out on eBay looking for some other boards, and that's when I found what I'll call a blue version board. And this one's got a much beefier heatsink on it. And the inductors are much thicker if we compare the two here. You can see how much thicker these inductors are than these, and I can't see the wire in here, but just look at the differences in them. I mean, this is a much more substantial heatsink, and it still has that power switch on here, still has the diode down here that I don't like, but this board was at least a little bit better. I actually haven't even had a chance to test this board yet, because that's when I found this beauty. This is a nice TPA3116 kit. And this is available from Jerry's Electronics. I'll give you the website here. jerryselectronics.com. You can find them on the web. He sells these on eBay and through his web store. He has a number of different kits available. But when you look at this one, there's no switch on here. There's no diode in here, so you don't have any losses. And look at the beef on that heatsink. That's a nice big heatsink. And look at the size of these inductors. This is much, much better than this board here. Plus, I like that this has got RCA jacks on here. Nice heavy-duty inductors. I can almost see the wire gauge through there, but I'm convinced that these will easily handle 3.5 amps of current on there. But this actually comes as a kit. It's all through hole components. You get the board with the TPA3116 already soldered to the board, and but you have to solder on all these other components here. And I'll go over what's all inside of the kit here in a minute. But this one I did some testing on, and if you look at the data sheet closely, this chip is supposed to be rated for 50 watts per channel. But when you look at that data sheet, that is at 21 volts power supply, 4 ohm load, and at 10% distortion, a very audible 10% distortion. So it's a little bit misleading as to its power claims. This board, I actually ran at 24 volts, and I was able to get 50 watts per channel, both channels driven into a 4 ohm load at 1% distortion. Much, much better. I was actually able to get the rated power out of this board. This board I only ran at 21, maybe 22 volts, and I only got 30 watts out of it. I did not try and run this up any higher than that, but I may do some future testing on these boards and see where we get. This board, at full power, 50 watts per channel, 4 ohm load, 24 volts. This heatsink does get pretty warm on here, but not hot enough to burn you or anything like that. Not hot enough to be of any concern. So this is a really nice kit. I like that it has all standard through-hole parts. It's very easy to assemble. My only criticisms are, one, you don't get the manual with the kit when you buy it. You actually have to go to Jerry's website and download and print the manual yourself. But the manual is pretty well thought out. It gives you a complete list of all of the parts that are in the kit. It gives you basic instructions on how to assemble it. Nice, large board layout with all of the components easily marked on here. They even give you standoffs, things like that. And the other thing that was nice about this board that the other ones don't have is they give you jumper locations on the board here in several spots. And I opted to put headers on my board so I could easily configure the board in different ways. In case I wanted to ever test it in bridge mono or use it for some particular application, I've got the ability to run this either in stereo or bridge mono. So in stereo, you're installing these jumpers here, J3, J4, and when you look at the schematic, all this is doing is tying the shield of the RCA to ground. In fact, if you remove these jumpers, the inputs are balanced inputs. So you could actually run this with a balanced input just by removing these jumpers, which is another nice feature of this board. You can run the amplifier in bridge mono mode, which in testing they say is 100 watts into 2 ohms. I have not tried to test what this will do into a 4 ohm load at bridge mono yet, but that's one of the things that I'll do. To do that, you have to move some jumpers around on here, and it gives you the instructions on how to do that. The other nice thing about this is they include all of the resistors depending on what gain you want the amplifier to run at. And so I chose 26 dB of gain, which means you have to install a 100K resistor and a 20K resistor. And it shows you where and how to do that. That gives me just a little bit less than 1 volt for full rated output. If for some reason you needed more gain than that, you can change these resistors and say if you wanted to run an iPod into this or something that had a half a volt output or something like that, you could get more gain out of it to achieve full power. And we'll go over a little bit more about what that means when I do the unboxing here a little bit later on in this video. But they go through all kinds of things in here. They talk about what it does, how to install the heatsink, assembly tips. They even give you the schematic on here, which is very, very nice. And then they give you some basics of like which way the LEDs go, which way the capacitors go. So this is a true kit. You have to assemble it yourself, but it is a very nice kit. I was easily able to build this in maybe a half an hour it took me to build. If your skills aren't so great, it might take you a little bit longer than that. But this is a really nice board. I really like it. Good job, Jerry's Electronics. And I want to make sure everybody gets the word out. These are about $32, I think, on Jerry's website. $33, something like that. So a little bit more on eBay, like $35, something like that. Of course, the eBay fees kind of jack that up a little bit. So it's not nearly as cheap as one of these boards, but considering what you get for the money, this is a very good value for the dollar. You simply need a 24 volt power supply. I was able to go on Amazon and buy the cheapest one that I could find. These things, these are like $13. So, you know, altogether total for 50 bucks, you can build yourself a nice 50 watt per channel stereo amplifier. We'll review these power supplies in a later date. These are 24 volt at 6 amps, and they'll just barely do 6 amps, but they won't stay at 24 volts. Their voltage drops down to like 17 volts at 6 amps. But anyway, doing the math on this, if we're running this at a full 100 watts output, you know, you're going to need 7 amps of power supply to run this at full clip. Granted, under music listening conditions, even at heavy clipping, you won't be drawing anywhere near that. You know, just for momentary peaks, you might be getting close to something like that. But for sustained listening, even at the loudest volumes, you won't need that. But I chose larger power supplies. I like overkill a little bit. I want to make sure I've got all the headroom I need for it. Next up, I'll show you what comes in the kit, what all you get with it, and some basic assembly instructions and tips on here, and hope you like it. When your kit arrives, it'll come in 2 bags like this, and I recommend that you go to jerryselectronics.com and download the assembly manual, as there is a parts list inside. I will go through all of these parts and show you what they look like. There's a couple of things that you need to be aware of. When you first unbox your kit, I like to lay the parts out and make sure that everything that is on the list that I'm supposed to have is actually in the kit. So the first thing on the list is the PC board with the TPA3116 chip already installed. And I like to take a look at the board. Take a look closely at the pins, make sure there's no solder bridges in there. Just give the board a good inspection on both sides here. Make sure nothing looks out of the ordinary. Very nice board, very well laid out. Let this refocus. The second thing on our list is 2 1000 microfarad 35 volt electrolytic capacitors. These are these 2 large capacitors here. We have a 10 microfarad 35 volt electrolytic, which is this one here. Then we get into some ceramic capacitors, which I'm going to skip for right now because there's some gotchas here that we'll go back over and we'll take a look at. You want to go through all of your resistors. Make sure that all of the resistors that are on this list there should be 11 total. I like to go through them and look at the color codes as well as verify what they are with the multimeter, make sure that they're correct. You should have a 10K variable resistor. That's your potentiometer here, right here, your volume control. You should have 4 10 microhenry inductors, 2 LEDs, and these larger washers here are your LED spacers. Make sure that you install those on the LEDs first. I forgot them on my first build here. Got done with my build and looked and said, what are these for? And then realized what they were. So make sure that you put these under your LEDs before you put them on the board there. You should have 3 2-position terminal blocks. These are your power and your speaker connectors here. You should have 2 phono jacks, 1 heatsink with 2 screws and 2 washers, and then some heatsink compound, and you should have 4 circuit board standoffs. Now, when we look at this list for the ceramic capacitors here, there are a couple of gotchas here that I want to go over, and this is one of the areas that I hope Jerry's Electronics may be able to change here in the future. And I don't know how far I can zoom in on these, but the numbers are printed on these capacitors are very hard to read. You have to use a magnifying glass or a jeweler's loupe to get in here and read the numbers. But the 684Ks are the larger of these capacitors. They're pretty easy to identify. The 224s they're shaped a little bit differently. Can we zoom in here? How far? Oh, that's even better. I wonder how far, if you can read that or not. Let's take a look. A little bit too far. 684s are the larger. The 224s are very small. But here's the biggest gotcha. There are 4 106s and a 105, and they all look exactly the same. In fact, even looking through a jeweler's loupe, the 105 looks very close to a 106. The 5 and the 6 are very look very similar under a microscope or under a jeweler's loupe. You have to really make sure that you've got the 105 separated from all the rest. I really wish this was a different color, or at least had a white dot on it, or was in a bag, or somehow it was easier to identify what that is. Then you should have two 104 capacitors, which these are much easier to read. The letters on these yellow capacitors are much easier to read. So go through your list and make sure that all of these are here. You should have 4 684s, 4 224s, 4 106s, 1 105, and 2 104s in your kit. When you start to assemble your kit, they suggest inserting R3 and R4 first. So if we look on our list here, we can see R3 and R4 is here. And if we line up our board in the same way this is on here, R3 and R4 are here. And if we zoom in here, we can see that R3 and R4 is here. I like to use these, I think they're jeweler's pliers. Let me see if I can get this to focus a little bit better for you. They have round tips on here for bending resistor leads. And with these, you can come in pretty close to this body here. I don't know if I can get that to focus very well. And bend these leads down, and they'll fit into the board pretty well. Of course, and it won't focus. There we go. You can see it. Something like that. Insert it into the board here, being careful to make sure that the leads aren't bent out too far. They should sit through the board fairly flat like this. You can bend the leads out a little bit if you need to flip it over and solder it. Go through all of your resistors first here. R3, R4, R5, R6, R7. Then they want you to start doing the capacitors, the small ones. And it's nice that the kit tells you to install the 106s. So again, next we're going to go through these 106 capacitors here. Again, I will warn you to make sure that you have the 106s and the 105 separated. The 104s are the yellow ones. Then you've got the single 105 here, goes in this location C5. Now, I don't know what would happen if you had one of these reversed, but for a successful kit, make sure you've got the parts in the right order here. Then you work your way up to the larger capacitors, the 224s, the 684s, gradually working your way up to the bigger capacitors, 10 microfarad here, your LEDs, phono jack, then your terminal blocks, then your inductors, then your largest electrolytic capacitors, then your volume control. Now, let's talk about the volume control for a second. This was another little nitpick of mine with this kit. I don't particularly care for this volume control because I don't like how this sits on the board. And here's another thing to look out for. When you get the kit here, there's no protection for the pins on this volume control, so they're bent every which way. So you got to kind of come in here and get them straightened up first, so it'll actually fit into the board without breaking any of these pins. You don't want to bend these too much here. Just get them straightened up a little bit. Oh, and of course I'm doing this off camera here. You want to just get these straightened up just a little bit. So that way when you go to insert this into the board here, you got to get all 6 of these little pins to line up first. And then you've got to get these 2 tabs on the side here. And of course, I'm probably not showing it. There's a tab here and a tab here that has to fit into the board. And it's going to take a little bit of force and a little bit of effort to get those to line up and for this to sit in here correctly. There we go. We got it to sit in there now. Now you can easily flip it over and solder all the pins in the back. But I don't like the way that this volume control sits. I put a knob on mine to make it easier, but if we pull this off for a second here. You know, when you're working on this board, it's just sort of in an inconvenient place to be up here next to this heatsink and over all your connections. It would be nicer if the volume control was maybe this direction, where you would turn it this way, or I guess you can also leave, alternately, you could leave this volume control off. and use a remote mounted volume control. When you look at the schematic here, the volume control is right here at the input between the RCA jacks and the input of the chip. Your signal comes into the RCAs through the RCA jack, through the volume control, through two DC blocking capacitors, and then directly into the chip. So if you're going to mount this into a case, you can leave this volume control off and just add two jumpers in here in place of the volume control. In fact, you could even leave the RCAs off if you wanted to and mount the volume control onto your case, have RCAs on the back of your chassis, run the signal from the RCA jacks up to your volume control, and then down to the board here and straight into the chip. That's what I would do if I were going to mount this into a case. If you're just intending to connect this up on the bench and play with it, you can put the volume control in here. You could always remove it later on. It takes a little bit of effort to get it in there. You take some time and practice and make sure you can get that in there without damaging any of the other parts in here before you install it. When you go to install the heatsink on the board, there's a couple little tips for this. When you go to put the heatsink compound on here, I like to squeeze it a little bit so you mix it up. Sometimes the fluid in here falls out of suspension, so I like to mix it up a little bit before applying it. Jerry also notes to apply the heatsink compound to the top of IC1 or to the heatsink. Don't worry if you use too much. Okay. You can use too much. It won't harm anything, but I can't tell you how many times I've seen amplifiers come in that have been done by other repair shops, and they are just gooped with this heatsink compound all over the place. You don't need much. Because I do a lot of amplifier repair, I've got my own thermal compound that I use, and it just takes a small amount. I mean, you really don't need a whole lot on top of this IC, and even what I have on here is too much. That is really all you need. If you can see that, there's not much on there. You don't really need a whole lot. You don't have to paste it all over the place here. The other thing that I found is that these washers that are supplied are slightly thicker than the chip. So I like to take these washers, put them on a little bit of sandpaper, and just sand them down just slightly. So that way when you put the heatsink on here, it is sitting flat on top of the chip all of the way, and the washers aren't holding it off of the chip. Jerry also recommends, there's a little tip here, you can put a little dab of this heatsink compound on the board right here where these washers will sit, and that will help the washers from falling off of the board when you go to try and stick the screw up through the bottom and you're trying to hold the board and the heatsink on here and get a screw underneath here and hold a screwdriver and do all of this at once. A little bit of heatsink compound right there will help hold these washers in place, one on either side, as you go to assemble this heatsink. Also of note, there is no DC protection for polarity on your DC input on here. There's no diode in here. There's no protection mechanism. It's not fused at all. So you have to pay particular attention to the positive and negative coming into this board. You want to make sure that you've got your positive going to the positive, your ground going to ground, or you could damage the chip. In fact, you will damage this chip if you connect that backwards. It is highly recommended that you add a fuse between your power supply and this board. Especially if you're going to mount this into a chassis, I would mount an external fuse holder onto the chassis. You want to make sure that fuse is rated for, I would say 7 amps, you'd probably be good. This board, in testing at 50 watts per channel into a 4 ohm load, I was drawing a little over 5 amps of current from this. So a 7 amp fuse should be good on there. Also of note, we should talk about power supplies a little bit. I went to Amazon and bought these 24 volt 6 amp power supplies. These are being sold all over eBay and Amazon. They're about 13 bucks. And they'll work, but they're not very good. They're rated for 6 amps. However, in testing on the bench, you start getting over 5 amps of current draw and the voltage starts dropping. By 6 amps of current draw, the voltage had dropped from 24 volts down to 17 volts. So These will work under normal operating conditions. Even at the loudest music, these should work just fine. They're just not a very good quality power supply. And especially if you're going to do any sort of bench testing, this will not support full volume, full 50 watt per channel on this power supply. Maybe we have to find one that's 24 volts at 10 amps if they're this underrated, because this is really maybe a 4 amp supply, 5 at the very most, but I think this is really about 24 volts at 4 amp supply, and I think they just are cheating a little bit here. So use a high quality supply. Power supply makes all the difference in the world. You want a regulated supply, clean current, lots of power available. It makes the difference. Let's talk about gain for a second, and specifically, what does this term gain and these numbers mean to us? In this setting, this is the amount of input voltage to output voltage. For my amplifier, I set it for 26 dB of gain. And we know that to achieve 50 watts, we need about 14 volts of output. So doing the math, at 26 dB of gain, that means that 0.7 volts of input will get us 14 volts output, or full power. So going through the numbers here, if we needed the amplifier to be a little bit less sensitive, we could set it for 20 dB of gain, which means that it would take 1.4 volts in to achieve full power. If we were doing some application where we needed it to be a little bit more sensitive, like let's say we were going to use this with an iPod, which has a very low output voltage, we could set our gain for 32 dB. And that would mean that it would take 0.35 volts of input to achieve full output. Or if you were going to use this with, say, a microphone or some specialized application where you need it to be really sensitive, you could set it for 36 dB of gain, which means it would take 0.22 volts in to achieve full power. Now, the higher the gain, the more noise you're also going to have. So at this setting, at 36 dB of gain, you might hear some audible hiss in the speakers. So you want to be aware of that. You want to set the gain to match whatever source you're going to use it for. 1 volt is a pretty standard output level for most devices, so I chose 26 dB of gain. And with my amplifier, with the volume control full up and my ear to the speaker, I can just hear a tiny bit of audible hiss. It's not bad at all. If you're going to use this in a professional application, like with a balanced output, then you'd probably want to set it for the 20 dB of gain setting, as balanced audio outputs on pro audio equipment typically are a little bit hotter than consumer levels. You'd probably want the 1.4 volt of input and adjust things for the 20 dB of gain. So I hope that helps understand this gain section a little bit and what those numbers mean to you. Well, there you have it. I hope you enjoyed this video. This is a really nice little amplifier kit. I quite like it. Compared to these other little boards, these boards may work for low power applications, but this is just a much nicer board. And if you've got the ability to solder and put a kit together, that's half the fun, is building the kit. Lots of good options, great board. Thank you for watching.